So the talk, if you read about my talk before you came here, I think it was called Prions, Agents of Change. And while I think that's an accurate description, as I tried to pull together the things that I wanted to talk about and the things I wanted to tell you about prions and the diseases they cause, I realized that was it just didn't cover it, and I couldn't think of a really good title that would touch every aspect of prions, so it's now called The Talk with No Name. And here's what I'm going to do. I'm going to talk about 4 brain diseases. Not all of them affect humans. Not all of them are actually caused by these weird agents called prions. But together, they will give you a picture, I think, of just how profound the science is that studies prions, that tries to understand them. And in fact, although I'm going to talk about the past a little bit, the most important thing is, where is this science going? So, I want to begin in Papua New Guinea. This is North America, but we're going to Papua New Guinea. In the 1950s, in the eastern highlands of Papua New Guinea, particularly centered around a little town, a little settlement called Okapa, a strange disease was discovered by Westerners, and in fact, the 4A people that the disease was striking, told people that first came to investigate it that the disease had only existed within their group since about the 1920s. Here's another map just to give you a better sense of eastern highland of Papua New Guinea, and where this disease was concentrated was in here, in one group. It's not really a tribal group, it's more of a linguistic group. But every year, dozens, if not hundreds of people were dying from a strange brain disease. Now, you know, I want to correct one impression you might have, which is that it's often referred to as the jungles of Papua New Guinea, but in fact, if you look at this map and see the number of settlements, this is not impenetrable rainforest jungle. These people were farming, they were growing yams, they were raising pigs. It's a highland area, but it's fairly open. But there was this strange disease. I'm going to show you a little bit of video shot in the late 1950s, film of course originally, that will give you a sense of it. But it was clearly a brain disease. First it affected coordination. Eventually people were unable to walk by themselves. Then they were unable to get up. Throughout most of this period of time, they were still mentally intact. But in the end, they became slightly demented and invariably died. There was not one person who got this disease called Kuru who lived. Here's some of this footage. Now this gives you an idea of who the typical patients were. This is obviously a young boy who's still mobile by himself, but this woman cannot walk without help. So you've got women of all ages, you've got young boys and young girls, and here's a poor kid who can hardly get up by himself. It was a mystery. The man who almost single-handedly started to unravel this mystery is that man right in the center there with the white t-shirt, Carleton Gajdusek. Honestly, I could talk for the next 40 minutes about this guy because he is a medical doctor, a brilliant medical doctor, went to Papua New Guinea, was intrigued by this disease, but also full of empathy for these people who were dying from something that they thought was sorcery. But he had so much energy. I was telling Neil Cashman, who you'll be hearing from later, that I took 2 books out of the library the other day, a total of 680 pages. And about 80% of those books were single-spaced letters that Carleton Gajdusek had written over a course of 3 years. He was writing voluminously, he was investigating the disease, he went on a 1,500-kilometer hike to try and delineate the borders of this disease in the Eastern Highlands, and at the same time was trying to collect blood, collect urine samples, trying to get to the bottom of this disease. Well, it became clear, or it was clear to Gajdusek and anybody else, that it was a brain disease, so he started trying to persuade the 4A people to allow him to do autopsies in the Eastern Highlands with the crude tools that he had, and sent tissues that he'd gathered at autopsy all the way back to his lab at the National Institutes of Health in Washington, D.C. And they did have enough formaldehyde, and they were able to freeze tissues so that eventually he was able to send brain tissues away for investigation. And it was a good thing he did too, because the nature of this disease completely bamboozled him. It should have been an infection, and yet there were no signs of infection. No fever, no inflammation, no strange proteins showing up in cerebral spinal fluid or in the blood. So what else could it be? Could it be genetic? That seemed pretty strange, because if it were true that it had only been around since the 1920s, and yet it was so common, you would think if it was actually genetic, it would have wiped them out a long time before. Could it have been a toxin that only women of all ages and young boys were ingesting? Could they have had, say, different diets from mature men? Well, Gajicek at one point said, there's 500 possible sources of toxins here. There's no way that anybody can analyze them. The big break came in the late 50s in two ways. Some of the brain tissue he sent to Washington was analyzed by his colleague Igor Klotzo, and Klotzo said there are some really striking things. For one thing, these star-shaped objects called astrocytes are very common and very unusual in appearance. You don't see this many of this particular shape in normal brain tissue. And Klotzo also mentioned, or was struck by the fact that in these brains, from Kuru, people who died of Kuru, there were these strange, dark deposits. And he said, I can't really help you, this is Klotzo writing back to Gajicek, but the only disease that seems even remotely familiar to this is a rare human disease called Creutzfeldt-Jakob disease. And he said there are only about 20 cases. But it was an extraordinary insight by Klotz that he recognized this similarity. Some of these images, some of the very images, in fact, the first image that I showed you, became part of a traveling exhibit about this strange disease. It went to the Wellcome Medical Museum in London, and a guy named Bill Hadlow, who was an American, happened to be in England, went to see this exhibit. Hadlow, at the time, was studying a different disease, a disease of sheep, one that had been known for quite a long time, called scrapie. It was an odd disease that caused the sheep to want to rub up against things, and they eventually lost a lot of fur, and they had some movement disorders, and they died. He also noted these astrocytes, and he said, that looks a lot like what I see in the brains of sheep that have scrapie. And he also noted these basically holes, spaces, vacuoles, all through the brain tissue of Kuru patients. And he said, and again, there's another image, this again looks a lot like this sheep disease, scrapie. Now there's a sheep with scrapie. You can see it's actually rubbed off most of its coat in this little sad piece of video I'm going to show you here. That's what happens when a sheep comes down with this disease. Now, this disease was known to be an infection caused by something like a virus, but a very, very slow one. So whereas you and I get a cold or we get the flu and it might incubate for a couple of days or 3 days, in sheep it took years for this apparent virus-like agent to cause disease. But here were two really interesting connections. Gajicek, all alone in New Guinea, not knowing what this was, can't see why it's an infection, there are no signs of infection, and yet these two other scientists say, look, there's a connection to this human disease, Creutzfeldt-Jakob, and there's a connection to this sheep disease. And that's what started the whole investigation. This is a brain, this is a scrapie brain, a sheep brain with scrapie. See all the little vacuoles, the little holes, like that, and like that. That's what Bill Hadlow seized on. And that was really the first break, because now Kuru looked like it was something that was very closely related to a disease, albeit in sheep, that was much better understood. And when you put all these things together, here's what people started to see in the early 1960s. Normal brain tissue there up on the left, none of these things, but here you get plaques, these dark deposits, you get vacuoles, and all of these, Creutzfeldt-Jakob disease, Scrapie, and Kuru, all look about the same. The story about Kuru is quite fascinating because it turned out, it's a long story which I'll skip, but it turned out that the agent causing Kuru was spread by cannibalism. So this group of people, the Foray, had started to conduct funerary feasts. When somebody in the family died, they would have a funerary celebration, ceremony, and they would consume the body of the deceased. And actually, in their view, it would be kind of stupid just to bury it. That would be a waste. So they did this with a certain amount of reverence, but it was quite apparent that what was happening was they were consuming all parts of the body, including the brain. The brain was probably loaded with these infectious agents that we now call prions, but at that time they weren't sure what they were. And so the disease was spread. Why was it confined to young boys and women of all ages, but not older men? Because young boys only lived with their mothers until they were about 8 years old. And then they went to live with the men. And the men generally didn't partake in these feasts. So young boys, young girls, and older women all were being exposed to, and it became very controversial because cannibalism is a controversial topic. And in fact, no Westerners actually witnessed one of these funerary feasts. But the Foray talked about them quite openly, and it's now pretty much accepted that that's the way the disease was spread. Because when the Australian administration, who after the Second World War sort of took over New Guinea, started discouraging cannibalism, and it's thought pretty much that it stopped around 1960. After that, the incidence of Kuru started to drop quite steadily. So at first you weren't getting any young boys anymore or young girls because there were no feasts. And then gradually you weren't getting teenagers and so on as time passed. But I'm going to come back to this if I have time, because there are still, cannibalism stopped in 1960, there are still older people in New Guinea who are dying of Kuru, which means they've been incubating the disease for 50 years. And that has some relevance to my next topic, which is this: mad cow disease. So in the mid-1980s, in different parts of England, small numbers of cows were starting to die with unusual symptoms. They became uncoordinated, aggressive, apparently confused, would startle easily. This is a report from 1987, before mad cow disease was even recognized. And you'll notice that at the very bottom, whoever filled this out, the vet who was consulting on this particular farm and this particular cow, described it as a new Scrapie-like syndrome. So he had already seen in the brain of this deceased cow that it was something like the well-known sheep disease in England. Scrapie had been in England for at least 250 years. Mad cow disease started slowly. This is just an image of, the cows would stagger, they would fall down, they couldn't get up. But it started to spread incredibly rapidly. So, before 1988, you had, dozens perhaps. But look at the numbers. By the time you hit 1993, something over 40,000 cows died each year from mad cow disease. The numbers are absolutely staggering, although I have to say, even though I have this graph, it himself seems a bit exaggerated, because the total number of cows that died over the course of this epidemic is supposed to be about 180,000. If you take the time, as I did this afternoon, to add up all those, it comes to more. So, but the shape of the graph is what's important. Why did this disease, like Kuru, fall off and eventually virtually disappear? Because at around these points early, they stopped the process that seemed to be propelling this disease. Here's what happened.